Hey everyone, welcome. So in this lecture, we will talk about this Pandas package. It's a very powerful library that we can use to process and analyze tabular dataset. For example, those saved in .csv format. And the most commonly used Pandas object is called data frame. So it's a two-dimensional data structure that stores data similarly to a table. We have rows and columns. And in this lecture, we will cover the commonly used Pandas functions and how we can use this to manipulate tabular dataset. And to work with any library, first we need to load the library in Python. So Pandas is already installed on Google Colab. We do not need to install it again. And all we can do is just call the library using this import option. So we're gonna say like import pandas as PD. So we are using this shortened version of this library name um, so that like next time we use this in this notebook, we will refer this library using this abbreviated format. Now let's create a pandas data frame from scratch. And one way to do so is by first defining a dictionary. And we all know that dictionary has key value pairs, and those keys will be representing the column names in the data frame, and the values will be representing the um, list that contains information about the data for the corresponding columns. And that list can be of any data types, for example, integers, strings, floating number, points. And since these data frames are structured as table, all of this list containing the column values need to be of same length. And after defining the dictionary, we convert it into a pandas data frame using this pd.dataframe option. So here you can see my dictionary called data, and I have three keys: name, age, and city. And I also have corresponding information for 3% saved as lists. And then I'm converting the dictionary into a pandas data frame using this pd.dataframe function, and inside the parentheses I'm putting the dictionary name here. And here you can see my final the data frame I just created. All right, so there's another way of doing this. So we can initialize an empty data frame first by this saying the column names and a predefined number of row, and then we can populate it by assigning values to each column. For example, in this case, I am saying that this data frame will have three indexes. In other words, it will have three rows, and the column names will be name, age, and city. And once I have that, again, I will create three lists for each column and then assign the values, like assign the list values to each column. So I'm saying like df dot name, which is the column name, will be equal to list name. And then I'm saying like df dot age, the column name, will be equivalent to list age, and similarly for the city. And it also produces the same data frame as we did before. Now we can add any list to the data frame as a new column. And here you can see I have new information stored as list for this 3 persons income. And I can just add this list as a new column in the data frame. I can call like df dot income, which will be created as a new column, and then I will store the values from the list income within this data frame. And here you can see the updated data frame. Now we have a new column called income, and the corresponding informations are extracted from the list. Now, like you already have seen this, that we can access specific column in this data frame using this df dot column option, which is this second one. So you've seen like I'm extracting specific columns by putting the data frame name, period, and then the column name. And there's another way of doing so. We can put the data frame name first and then square brackets and then inside the quote the column name. Either way, both of these cases, we will extract information for a specific column and it will return a pandas series object. So this is a one-dimensional array containing the values of column along with the index. Now, there's this dot lock function, which is a very important function we can use to slice and access specific rows and columns in a pandas data frame. And this lock function creates these data subsets based on the index information and also the column names. And within the square brackets of the lock function, we first put an index range based on which we will create the slicing and then a comma. And after that, we put the column names. And here, for this particular case, remember that dot lock includes both the start and end index in the slice. Here you can see an example. So I am creating this new data set as a subset of the df function. And here I am saying that create this subset and only include index values 0 to 1. And that means the first two rows and include column name and city. And if you do not provide any start and end index values, it will return all the rows for those particular column. Like in this case, I do not have any start and end index, so it's returning all three rows I have and only the column name and city. If you do not provide any column name, it will return all the column values, but only for the specific index range. For example, here there's no column name, so it's returning only the rows with index values 0 to 1. Now, you can also access only a specific value located at a given index and column position. And for example, let's say I want to extract the city name at index 2. So here you can say just df.log and the first number we put is the index value and then the column name. So it's saying that the city name located at index 2 is Chicago. And then we can update this information as well. For example, we want to change the city name at index 2 from Chicago to Indianapolis. In that case, we can do the same thing and then an equal sign, and then we can say, hey, update it to Indianapolis. And here you can see the updated data frame. And now at index 2, which is our third row, the new city name is Indianapolis. And also you can use the .log function to add a new row to the data set. So far we had only index values up to 2. We are adding a new index value 3, and we are providing the corresponding informations as a list, the name, age, city, and income. Now, we do not always create the data frame from scratch. Sometimes we import from existing data sets. And we already learned in our lecture 1.2 that there are many ways to load data from our local machines to Google Colab. And for this particular lecture, we will use this median household income data for Virginia census tracts. You can download this download this file from Canvas, and this data set is collected from this link. In this particular case, we are using the files module. So if we run this, it's asking us to upload a file from our local directory. And here, like you can just go where you have saved the file and then open it. It will be uploaded to Google Colab folder. And if you go to this Files tab on the left side, you can see that this file has already been uploaded. All right, so once it's uploaded on Google Colab folder, and then we can import the file using .read_CSV function, and then we can just inside the parentheses we can put the file path or file name, and this data is already loaded in the Google Colab directory, so we can just provide the file name. That should be okay. And here you can see that I'm writing that pd.readcsv and within the parentheses the file name, and here you can view the data frame. So this data frame, it contains information about median household income and for all census tracts of Virginia. And you can see here that we have 2,197 rows and 8 columns. And this value particular, these values represent the median household income for all the census tracts. Now, this data set is quite long and we cannot see the entire data set in the Python window. And in this case, Python, like Pandas has several built-in functions that we can use. For example, we can use this dot head. It will return the 5 first rows of the data frame. Then dot tail, it will return the last 5 rows of the data frame. Dot info, it will provide a summary of the data frame, including column names, non-null counts, and what type of data for each column. You can also use dot columns to print all the column names in the data frame. Then dot shape to return a tuple representing the number of rows and columns in the data frame. Here you can see an example of all of these functions and how I called them. For example, this one, medium income dot shape. So it's giving us a tuple. The first value in the tuple represent the rows, number of rows in the data set. And then the second value represents number of columns. And then this median income dot column is also printing all of the column names within the data set, which can be very handy sometime. Now, we can use the comparison operators and Boolean operators to filter or subset any Pandas data frame. So the comparison operators, the syntax are as it is, greater than, less than. The not equal to would be exclamatory sign and then equal sign. And for the Boolean operator, the syntax is a little bit different. So here you can see the syntaxes we use for representing or and not Boolean operators. Say we want to filter our median income data set and create a data subset based on like considering these two criteria. We want all the all the census tracts that has a median income greater than 20,000 and only rows corresponding to census tract 3.01. And here I can first call this data frame name, and then within the square bracket I have my first um, first criteria, that is the median income value greater than 20,000. And then I have my second criteria, that is median income, and tract information should be equivalent to census tract 3.01. And you can see that based on this criteria, we got this new data set that contains only 3 census tract that fulfills our criteria. Now, the large data set will always have some missing information, and there are multiple ways you can acknowledge those. So for example, here you can use this .isNull function that will return the data subset with missing median income values. So how do you recognize this missing information, like missing data? You will see this NaN, and that stands for not a number. So this indicates that there's no information, there's null value for this particular location. And here, again, I'm filtering the medium income data, and I'm saying like median income, and within the square bracket, I'm putting the filtering criteria, which is median income and value. If it's null, then keep it within the data set. And here you can see like all it's returning the data subset I have, like, and all of them has a median income null value. So we do not have median income information for this census tracts. Next, so we can drop these rows with missing median household income values using the dot drop NF function. And inside the parentheses, we can put the column name based on which we want to drop the information. In our case, the column name is value, which is which represents the median household income. And so now here you can notice that our with this new data like with this new code, our like this medium income data frame now has 20,151 rows, which was 20,197 rows initially. So we excluded all the rows that has null values. Also, like instead of putting any specific column information, you can drop all rows that contain missing values. In that case, just do not provide any column name inside this parenthesis. And in our case, it will return the same data set because like all other columns in this data set didn't have any missing values. Now, we can also fill the missing data points using a values of our choice and using this dot fill NF function. So what we essentially do, we say that first we put the data frame name and then dot fill NF function, and inside the parentheses we put the value we want to fill it in. So if here I'm saying 0, so I'm saying like replace the null values with a 0, and the output will return return a replace data frame where all the null values are replaced with 0. We can also create new column in the Pandas data frame by calculating their values from the existing column, and we can use various control flow operators for that purposes. So here I'm showing an example. So suppose we want to create a new column and that contains zeros and ones, and we want to like decide the 0 and 1 based on the criteria. If the census tract has a median household greater than 50,000, then it's going to be 1. If it's less, then it's going to be 0. And here I'm using a list comprehension to create this new column. I'm saying like medium income, then create the column above 50K. And then here goes my list comprehension. It's going to be a 1 if medium income greater than 50,000, else 0 for all the values within range length, the medium income data set. Also, we could have used conditional statements here. For instance, if we want to create a new column that categorizes the census tract into high, moderate, and low income tracts based on their median household income, we could have used just a for loop. So first we initialize an empty column and we put the column name as tract category, and we are assigning the values as null string. And then I'm saying like for all the indices or all the rows in range length the data, which is median income, if the median income for that particular row and value column, if it's greater than 50,000, then the tract category information for that particular row I would be high income. Else if the median income for that row and value, if it's less than 20,000, the tract category would be low income, else the tract category would be moderate income. So here using this I, we are reaching out to each specific index and the column information, and testing our conditions, and based on that, we are updating this track category information. We can also compute summary statistics for all numeric columns in the dataset, and for that purpose, we can use the .describe function in Pandas. And the Pandas returns the key statistics. Like with this .describe function, it returns the key statistics, for example, like minimum and maximum values for all the numeric column we have, and then the average, the standard deviation, and also the quartile values. So 25th, 50th, and 75th percentile values. For example, in this case, we had 4 numeric variables or numeric column names in this medium income dataset. The year geoid value, which is actually the median household income, then this above 50K we just created. However, other than this value column, none of these descriptive statistics make any sense, and we don't even need them at all. So here, instead of using this .describe function, we can also obtain summary statistics for specific column by indexing with the column names. What we can do, so first we can call the particular column name. In our case, for example, medium income, and then referring to the column name value, and then we are saying dot mean parenthesis. So it's extracting the mean values for this value column of median income dataset. Same, it's extracting the median value for this value column of this medium income dataset. And it goes on and on. You can find the standard deviation, mean, max. So all of this information for this particular column. And also you can use the .unique function to extract the unique values. In our case, you can say like how many unique categories we have in this tracked category. So we have moderate income, high income, and low income. Next, we can use this group by function to split the data into groups based on one or multiple columns and then apply aggregation, for example, mean, median, value counts. So this is also very useful when we want to categorize the data set or summarize the data set based on multiple column informations. And here's one thing to remember. The group by function typically returns the output as a group data frame, and it will not have the standard row index. To convert it back into a regular data frame, you can use the .reset function and ensure that the grouped values become part of the data frame structure. So what we're going to do, how do we call this group by function? So first put the data frame name, that .group by. Within the parenthesis, you put the column name based on which, and the column name based on which you are gonna do the grouping, and then you put the column name based on which you are gonna do the aggregation. So in our case, I'm saying that do the grouping based on the tracked category, the high income, low income, and moderate income, and then for each category, calculate their mean values, calculate their mean, median household income. And here you can see the output. So we are doing the grouping based on track categories and finding out the corresponding average median household income values. And we can use multiple columns to group the data set. For example, in this case here, I am saying group the data set based on county and track category. So now for each county, we will group them based on high income, moderate income, and low income category. And then for each of those category, we will calculate the average of median household income. Lastly, we can use the .toCSV function to export the data to a .csv file. And once we run the cell, you can go to your collab directory and see how the data has already exported to the collab directory. For example, in my case, I am giving it a new name. First of all, the data frame that I want to export, and then dot to CSV, and inside the parenthesis, I am saying, okay, save the data or export the data using this name. So medium household income, VA tracks, new data .csv. So everything we have done so far will be saved into this new location. And you can see here the new, you can see here that the new data has been exported there. So that's all I have for this lecture. And in the next one, we're gonna talk about GeoPandas and how we can do spatial data processing in the same ways. Thank you so much.